So is the screen visible to all?
Yes, sir.
Okay. So if anybody has any doubt, you can simply type in the chat box, or you can also just interrupt me, or just ask the question after the problem is solved. So let us begin the session. So good evening, everyone, and I welcome all of you to the first live session of the course Concepts of Thermodynamics, which is being taken by Professors Dr. Suman Chakravarti and Dr. Aditya Bandyopadhyay. As in for myself, I am Abhik Deb, and I am a PMRF Fellow in the Department of Mechanical Engineering at IISc. I shall mostly deal with the live sessions wherein we will be solving some problems related to the concepts that have been discussed previously in the class, so that the some of the doubts that you might be having related to the concepts or the numericals can be solved here, can be cleared here. So I request all of you to be present every Friday between 6 to 7 p.m. and make this outreach a success. So without further delay, let us move on to the problem. Uh, we will start with a very basic problem in which uh, so I hope that everybody uh, has attended the first week lectures. The phase change processes and the PVT diagrams have been discussed, I hope. And so, are all these concepts clear to you all? Anyone can just mute and answer. Anybody? So this is basically supposed to be a interactive session. So I hope that you people can answer. I'm audible to everybody, right?
Sir,
Yes, sir.
actually, the doubts we have, we are not written in paper. So,
Okay. But you have attended the lecture, right? The
yes,
Okay,
all the
so
lectures.
actually the doubts that you might be having with the concepts, you can also post them in the discussion forum in the NPTEL website. So the professor and the other TAs, they can also help you with the doubts there. And other doubts you can also ask pertaining to the problems that we'll be solving, you can also ask here. But discussion forum is also quite a helpful mean where you can ask. You can also see in the problems that we will be solving here, you can also ask the questions related to this in the discussion forum as well. So I will also keep an eye on that, and I will try to answer those there as well. So but it's better that you can ask here, the so that it can be cleared right away. Anyway, so let me start with the problem here. So yeah, so the temperature of water is increased from -30 to 140 degrees Celsius, keeping the pressure constant at 550 kilopascal. So which among the following statements regarding the phase of the water in this process is true? So there are four options given. One is that the ice sublimes directly from the solid to the vapor phase. The other one, that the ice melts into a liquid and remains as a liquid till the temperature reaches 150 degrees Celsius. and the other option, ice melts first into a liquid and then subsequently evaporates. And the fourth option is that none of the above is true. So regarding this, see, this is the pressure is given as 550 kilopascal. So we know for water, the critical point, there is something called the critical point and the triple point. I hope that these have already been discussed in the class. So uh, just a minute. Okay, so let me go back to this. So I hope you all know what are these curves. So this is the sublimation curve, this is the fusion curve, and this is the vaporization curve. So in sublimation curve, what the phase change, what happens here is the solid will directly convert to the vapor phase without undergoing without forming any liquid phase in between. This is the fusion curve in which the solid changes to the liquid phase, and this is the vaporization curve in which the liquid changes to the vapor phase. So the triple point is basically the point at which mm, all the three phases, that is ice, the water, and the water vapor, can exist in equilibrium. Below the triple point exists the sublimation curve in which the solid can convert to vapor directly. This is the critical point. The critical point is the point above which the liquid, there will be no boiling phenomenon. That is, the liquid, it will at a particular point it will directly convert to the vapor phase without forming a liquid vapor mixture in between. So above the critical point, that is the phenomenon. So the pressure of 550 kilopascal, it is above the triple point, so the sublimation cannot happen because the pressure somewhere lies in between. So let me write it here. So this is the 550 kilopascal, say. So let us assume that it starts from this point, minus 30 degrees Celsius, and it continues to 140 degrees Celsius. We don't know the end point of this, and we will figure it out as we move through the problem. So we can see here that, is somebody waiting in the lobby? So the option A, and the option A says that ice that ice undergoes a sublimation. So since this 550 kilopascal, it is less than the triple point pressure, therefore so ice does not sublime. It is not possible, because if it is above the triple point, then the sublimation curve itself won't come. So now let us consider the option C. See, it states that ice first melts into a liquid and then subsequently evaporates. So this 550 kilopascal, it is less than the critical point pressure. So it will somewhere lie in this zone. It cannot lie above. I mean, there will be a liquid to vapor mixture formed. If the solid converts to the liquid, if it crosses the fusion curve, then the liquid to vapor mixture will be formed, and it will not directly convert to vapor. So, and corresponding to 550 kPa, what is the saturation temperature? This is the saturation temperature corresponding to the vaporization. This equals to around 155.48 degrees Celsius, which is greater than the final temperature, right? So this ice cannot evaporate because the saturation temperature for the vaporization has not been attained yet. So ice to liquid won't evaporate. So the final option, that is B, the ice melts into a liquid and remains as a liquid till the liquid reaches a temperature of 150 degrees Celsius. Yes, it is correct, because 155 degrees till 150 degrees Celsius, which is also less than the saturation temperature of the vaporization, it will remain as a liquid. So the ice melts as liquid, melts into liquid, and remains as the liquid phase. So the correct answer is option number B. So if anybody has any doubt related to the solution of this problem, please do ask.
No doubt.
Okay, thanks. So let us then move on to the next problem. So we have to determine the missing properties of water. A table has been given, and we have to determine the properties that are missing. So this is, see, the pressure is given as 650 kPa, and the X is given as 0.6. What is X? X is basically the dryness fraction. So it implies that it is not completely dry. So since there is a particular value of X, we can say that the point that is being referred to here lies within the bit in between the fusion and the vaporization curves. That is, it lies in the liquid to vapor dome. So this is, can anybody say what is this? This is the steam table. I hope everybody is familiar with it at least by now. So this is the steam table in which the properties of saturated water, compressed liquid, and superheated vapor are all expressed in terms of the saturation temperature and or saturation pressure, and the properties like the specific volume, the internal energy, the enthalpy and entropy are expressed at these points. So we will be taking help of this table to find out what are the missing properties here. So let me start with the solution. So the 650, the pressure given is 650 kilopascal, which is, if we consider this table, that is 0.65 MPa, and the quality or the dryness fraction, it is given as 0.6. So you can see that the pressure that is given lies between these 2 points here. So we need an interpolation to determine what will be the saturation temperature corresponding to this. So T4 here is essentially the saturation temperature itself, because since the point that we are considering lies between the lies within the liquid to vapor dome, so this will necessarily be a saturation temperature, the fixed temperature at which the phase change is occurring. So we have to do an interpolation between these 2 points to find out what is the temperature. So by interpolation, this T4 minus 161.365, this becomes equal to see we have to take the pressure which is corresponding to these temperatures, these salient temperatures. So T4, it corresponds to this pressure P, so this is 0.65. This 161 corresponds to 0.64, so 0.64, and this is it corresponds to 0.66, and this again to 0.64. So if we carry out the interpolation, we will find that T4 becomes equal to 161.976 degrees Celsius, which is nearly equal to, you can say, 162 degrees Celsius. Similarly, by interpolation, see, this is the specific volume of the mixture at this point. So the specific volume, we know it is a function of the liquid specific volume and the gas specific volume or vapor specific volume at that point. So for that, since the point here is missing, so we have to do the interpolation between these 2 points to find the liquid specific volume and the vapor specific volume at the point that we are considering, or that is the point given in the question. So by interpolation, if we carry out the interpolation between the 2 points, we will find that the specific volume for the liquid is this. It comes out equals to, and the specific volume for the gas, it comes out equals to, so we already, I hope we know that this is the specific volume of the mixture. This is equal to 1 minus the dryness fraction multiplied by the liquid specific volume plus this multiplied by the gas specific volume. So if we put in the values, just put in these values, and x equals to 0.6, we will find that this things comes out to be equal to 17605. So we can write the answer here. The temperature T4 is equal to 162 degrees Celsius, and this T4, this is equal to 0.176 meter cube per kg. So regarding this problem, if anybody has any doubt, you can please ask. Anybody, any questions?
No doubt.
Okay, thanks. So let us then move on to the next problem. So here a pressure cooker has a lid that is screwed on top of it tightly. The lid, there is this opening of 5 millimeter square, and it is covered with a petcock that can be lifted to let the steam escape. So how much should be the mass of that petcock so that the inside the water can boil at 160 degrees Celsius. So this is the pressure cooker, and the opening at the top is covered with a mass which we are assuming to be m for now, and we have to determine it. and this area is 5 millimeter square, the area that the mass is covering. The atmospheric pressure is given as 100 kilopascal, and the water, we have to design it in such a way that the water boils at 160 degrees Celsius here. So what we are gonna do here, let us start with a free body diagram of the petcock. So the atmospheric pressure, it will insert a force multiplied by this area. This is the pressure, atmospheric pressure multiplied by the area, this area that it is covering. Similarly, from the bottom, let us assume that this is the pressure inside, and this multiplied by the area will be the force that the vaporizing water will will impose on the mass m, and this is the weight of the body that will act downward. Now, since the water is boiling here at 160 degrees Celsius, we have to design it for the boiling. So that means there is a necessarily a phase change. So corresponding to this, corresponding to 160 degrees Celsius, the saturation pressure, it is 618.23 kPa. So this is the pressure that it will be applied. This is the pressure. So if we perform a force balance, we will see that this atmospheric pressure multiplied by area plus the weight of the body, these are the forces that are acting downward, will balance the this saturation pressure. Let me write here saturation pressure of the water vapor mixture that will ultimately act on the mass m multiplied by area. So the mass m will simply be the saturation pressure minus the atmospheric pressure multiplied by the area A by G. So if we put in the values, this 10 to the power 3 because these are in kilopascal, so we are converting it to SI units, that is Pascal, and this is 5 millimeter square, so we will be converting it to meter square, that is 10 to the power minus 6 meter square, and this is 10 as given in the question. So this comes out to be equal to 0.259 kg or 259 grams. Sorry. So this is the option B here. So I hope this is clear as well. So any questions till now?
Sir, hello, sir.
Yeah, hi.
Sir, can you please explain last step once again?
Okay, which one?
Yeah, sir. After free body diagram, how does P saturated into area came on LHS?
Okay, okay, okay. So see, uh, this is the water that is being boiling, right? So the vapor that will form, it will exert a upward force on it, right?
Yes,
Yes. So the atmospheric pressure from outside, it will impart a downward force on this, correct?
yes, yes,
And the weight of the body, it will also act downward.
yes,
So the downward forces are what? The weight of the body and the pressure due to the atmosphere.
yes,
So the pressure force due to the atmospheric pressure and the weight of the petcock, these are the downward forces,
yes,
and the the pressure due to the vapor that is acting on the petcock, it is in the upward direction, right?
Sir, I didn't understand why. How does upward direction?
Okay, so suppose,
Resolution of forces of upward forces of the gases which it contained in the cooker.
see, yeah, yeah. So if you have ever observed, I mean, how when you boil something in a pressure cooker, what happens? See, in this, suppose if you are boiling this water, the vapor that will form, it has a tendency to move upward, right? It has a tendency to move upward.
Yes,
Have you observed anything like so have you ever boiled water?
yes.
So have you seen that the vapor, have you covered it with something?
No, sir.
So I mean, have you ever seen that the vapor is going upward? I mean, if you cover it with something, you will see that the moisture droplets are forming at the covering. This
Yeah,
is because that the vapor is moving upward.
yes,
Or have you ever seen the pressure cooker in operation?
yeah, yes, sir.
So the safety nozzle, that it moves up at a particular pressure, right?
Yes,
And it makes a hissing sound. So what happens? So this is because of the vapor that is forming due to the boiling, it is moving upward and it is trying to push it.
yes.
So as it is trying to push it, it is imparting a upward force. So at a
Okay.
particular you can say a particular pressure, at a very low pressure it won't move, but at a particular high pressure, at a particular threshold pressure, this balance will happen, and the um, vapor will move the petcock upward and it will escape. That is when we get the hissing sound in the pressure cooker.
Yeah, okay, understood.
So is it clear?
Yes, 100%.
Okay, so should we move on to the next problem?
Yes, sir.
Yes, sir.
Okay, okay, just a minute. Just check if it is being recorded. Okay, so this is a somewhat a bigger problem. So let us try to solve it step by step. A closed rigid container of volume 0.5 meter cube is placed on a hot plate. Initially, the container contains a two-phase mixture of saturated liquid water and saturated vapor at a pressure of 1 bar, and quality is 0.5. So quality is again the value x, that is the mass of the vapor present divided by the total mass of the mixture. After heating, the pressure becomes 1.5 bar. So we have to determine the temperature at the two states, the mass of the vapor present in the mixture in the two states, and the pressure in the container at which only saturated vapor will be present. Later we will focus on the third part later on. First let us focus on the first two parts. So in the stage 1, what is given, the mixture is at 1 bar pressure and the quality is 0.5. So after this it is heated in a closed rigid container, so the total volume remains fixed. So the temperature and the pressure will increase in this case, and the pressure here becomes 1.5 bar, and the the dryness fraction or the quality is, we are assuming it to be x2, which we have to determine actually. So since this is again a mixture of liquid water and vapor, saturated vapor in equilibrium, so this is a phase change process. So the temperature corresponding to each of these processes will be the saturation temperature at which this process is happening. So if we consider 1 bar as in, this is 1 bar, 1 bar as in 1 bar is 0.1 megapascal actually. So corresponding to that, the saturation temperature is 99.606 degrees Celsius, and 1.5 bar is 0.15, this 0.15 0.15 megapascal. So the corresponding saturation temperature is 111.349. So the temperatures that we have been asked to find in the two states will necessarily be these two saturation temperatures itself. So let me write it here. One bar T saturation is 99.606 degrees Celsius and corresponding to 1.5 bar, the saturation temperature is 111.349 degrees Celsius. This value. So the two temperature at stage 1 is 99.606 degrees Celsius and temperature at stage 2 is 111.349 degrees Celsius. So I hope this is clear so that we can move on to the next, the part B of the problem. If you have any doubt, you can please ask, else I will move on to the next part.
No doubt.
Okay. So the part B. See, we have been asked to find the mass of the vapor in the two states, that is corresponding to 1 bar and 1.5 bar. So this is essentially a closed system in which the volume is given, the total volume is given. So and we have to determine the mass. So how should we proceed? So does anybody have any idea how should we proceed regarding this? You can just unmute and say if you have any idea regarding this. What do we basically need to find so that we can proceed with the problem? Anyone?
Hello, sir.
Yeah.
Sir, as it is the closed vessel, the volume will remain constant,
Yes.
specific volume,
Yes.
but V1 equal to the V2.
Yes.
So to calculate the mass,
Yes.
the volume of the vessel is given there, total volume.
Yes.
Find out it pressure of 1 bar and the quality of 0.5.
Yes.
It is a mixture.
Yes.
Calculate the specific volume of this mixture.
Yes.
Then
Exactly. Exactly.
specific volume divided by the total volume, I
Yes.
think that is a mass.
Yeah. Yeah.
Then in the same way, equating V1 equal to the V2,
Yeah.
you'll get a
Exactly.
specific
Exactly.
volume of the at a state 2. So again, you'll get a mass.
Yeah. Exactly. Thanks. Thanks.
Sir, I have one not doubt.
Yeah.
In question number 1,
Yeah. Okay.
please can you show that slide?
Yeah. 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 Yeah.
Your solution is any correct, sir. Everything is any correct. Even P theta diagram also any correct.
Yeah. Yeah.
But critical point is 0.6 kilopascal, and the pressure of the steam given is 550 kPa. So this pressure is not a less, it is a greater than the critical point. That's why on the PT diagram, that process is above the critical point. If it is a less,
Oh,
then that's
sorry. Yeah. That is a yeah.
uh,
Thanks for ye. This will be
otherwise
yeah.
that
Yeah. Yeah.
options
Yeah.
will, if it is
Yeah.
a less, then options will be the
Yeah. Yeah. Yeah.
solid to
Thanks.
the
Thanks.
liquid, vapor,
Thanks.
vapor.
This has been a. I mean, while writing, it has been a error, I guess. Yeah, so yeah, below triple point we cannot have sublimation. So yeah, 550 will obviously be greater than the
Everything is
triple.
any correct, sir.
Yeah,
I
yeah,
know. I understood your answer is
yeah.
exactly correct. The
Thanks for pointing it
presentation of
out.
from that any point, I have in the mind how it is.
Yeah. 550. Yeah, it obviously the pressure has to be above the triple point pressure for
That's why that process you have shown
for the
correctly about
sublimation
the
to.
triple point,
Yeah,
and
yeah,
answer is your answer is correct.
yeah. Thanks for pointing it out.
Okay.
So let us continue with this then. So at this 1 bar pressure, the specific volume, you can see the specific volume is 0.00104315. So yeah, quite a big number, to be honest. Number a lot of digits. We can ignore a few, but let us not do that and continue with it. And the specific volume of the gas, that is 1.6939. So since the quality is 0.5, I guess, so at this quality we can find the specific volume of the mixture, that is the specific volume of the mixture in the stage 1, that is equal to this value. So this actually comes out to be equal to 0.8475. So what is this specific volume? The specific volume is basically the volume divided by the mass of the mixture. So this is the value. So this is the total volume that is of the container that has been given as 0.5 meter cube. And when divided by the total mass of the mixture, we actually get the specific volume at that particular state of point. So the mass here will be just the volume, the total volume divided by the specific volume value. This is 0.5, 9.8475. This comes out equal to be kg. So we have to determine the mass of the vapor in the two states. Since the quality is 0.5, what is quality? Quality X, that is the mass of the gas or the vapor by the total mass of the mixture. That is the quality, and this is given, this we have found out, this is 0.5. So the mass of the vapor in stage 1 will be what? 0.5 multiplied by 0.589, that comes out equals to 295 kg. So the mass of vapor in stage 1 is 0.295 kg. So let us now move on to the second uh, salient point, that is the stage 2 at 1.5 bar. You can see the liquid specific volume is 0.00105273. So and the specific volume of the gas is 1.1593. here I would like to mention one thing, that these steam tables, or the tables that we are using, actually these are although they, in every, you will find it in many sources from various textbooks. They are mostly included in the appendix part. There are some websites also which have these steam tables. In all of these sources there might be slight variations in the values. So your answer should pertain to the steam table that you are using. So as I am using this steam table, so my answers will pertain to the values that are given here. So if somebody is using some other steam table, the answers might vary small amount by small amount. It won't be a big amount, a big value difference, but it might vary by a small amount. So in this, so the basic concept here is that since this container is closed and rigid, so for a closed system what happens? So the total mass of the mixture will remain constant. This is because it is closed. Since it is rigid, so total volume will also remain constant. So this ratio, so volume by mass, this ratio, which is essentially the specific volume, it will also remain constant. So in this we can say that the total specific volume will remain constant. However, the specific volume of the liquid and the vapor will change from one stage to another, but the total will remain constant. Thus, this stage 2 specific volume is also equal to the stage 1 specific volume, which we have already found out to be 1.5. So here, what is the stage 2 specific volume? We can write it as these values are corresponding to the stage 2 liquid and the stage 2 vapor. So what will be the value of this x2? This will be equal to minus, if we take it to this side, it will be this divided by, so if we put these values from Vf and Vg, if we put these values, it will come out to be it. So the mass of vapor in stage 2 equal to this x2 multiplied by the total mass, which comes out 0.08 multiplied by 0.589. So this comes out equal to 4304 kg. So this is the mass of the vapor in the second stage. Now, so is everything clear till this point?
Yes, sir.
Okay, so then we will move on to the last part of the problem, that is to determine the pressure in the container at which only saturated vapor will be present. See, initially it had a quality of 0.5, right? So after this, on heating, the amount of vapor will gradually increase, as we have found from the solution that in the stage 2 the amount of vapor, the fraction of vapor, the mass of vapor becomes 0.7308 from 0.5. So if we apply heat further, what will happen, that the entire liquid will gradually convert to vapor. So in that stage we have to determine what will be the pressure inside the container. Okay, so necessarily part C, when only saturated vapor is present, what does this imply? Only saturated vapor, that means that there is no liquid. That means the mass of the liquid becomes zero, so the mass of the gas becomes equal to the total mass. This implies that this dryness fraction value becomes equals to 1 here. So if we write the net specific volume for the mixture at this stage, then V3, this is equal to what? 1 minus x3 plus x3 multiplied by the specific volume of the gas in this stage. So this is 0, this is 1, so this portion becomes 0 and this is 1, so this necessarily becomes the equal to the specific volume of the gas, that is the specific volume of the mixture will be equal to the specific volume of the vapor in this case, which is which can be directly said from the intuition, because only saturated vapor is present, right? So only the vapor, the whatever will be the volume of the vapor, that will be the volume of the specific volume of the mixture. So this the V3 value, and again from this logic that the specific volume remains constant throughout because the container is closed and rigid, so this will be equal to the gas, the specific volume of the vapor phase or the gas phase, this will be equal to the this one, that is 0.8475. Okay, so this is the specific volume of the vapor phase at this point, in which point we have to determine what will be the pressure inside the container. So this is still in the saturated region, this is still a saturated vapor condition, so we have to determine the saturated pressure which corresponds to this value of the vapor phase specific volume. See, for every specific volume, just as for every pressure there is a corresponding specific volume in the vapor phase, similarly for every, we can alternatively say that for every specific volume of the vapor phase there is a corresponding saturation pressure. So this value, it will also correspond to some value of the saturation pressure here, and we can see that this value, this 0.8475, it comes in between these two values. So the saturation pressure will be between these two values. So by interpolation, we have to do this by interpolation. We can say that this 0.8475 84614, we are taking this value divided by point, this difference, eight four six one four. So corresponding to this, we are actually determining the pressure, so let it be P. Corresponding to 0.84614, the pressure is 0.21 megapascal. Corresponding to this value, it is 0.2, and corresponding to this, it is again 0.21. So this we can say as P3 because it is the pressure at the stage 3. So P3 will be equal to this value, that is P3 minus 0. Let me write one more line. This is minus 0.01, and this value comes out to be equal to 0.0344. So if we solve this, we will define that the P3 is equal to 0.2096 MPa or 2.096 bar. So we have to, so this is the pressure in the container at which only saturated vapor will be present. This is this pressure that at 2.096 bar only saturated vapor will be present. So is this clear to everybody? If yes, then we can move on to the next problem.
Yes, sir.
Okay, so okay, then let us move on to the next problem. Essentially, this will be the last problem for today's session. So a pressure cooker, a closed tank, it is evident, contains water at 100 degrees Celsius with liquid volume being 1/20th of the vapor volume. It is heated until the pressure reaches 2 megapascal. So thus the final stage has more or less vapor than the initial stage. So this is the initial condition in which a mixture of water and vapor is present at 100 degrees Celsius in a closed tank, and the volume of the liquid is equal to 1/20th of the volume of the gas. Be very careful in this. This is not the quality, and it won't give the quality because this is the volume ratio. The quality comes from the mass. It is essentially the ratio of the mass of the vapor to the total mass. So this ratio is not directly related to the quality of the mixture, but we have to determine actually the quality from this step, from this given condition, so that we can proceed with this. So let's say, so at 100 degrees Celsius, this 100 degrees Celsius, so we the specific volume of the liquid and the gas phases we know. And this is 1.6718. This is also meter cube per kg. So this given condition, the total volume of the liquid is equal to 1/20th of the total volume of the gas. Now what we know, what is the volume? Volume is nothing but the mass. Volume is equal to what? Mass of the component multiplied by the specific volume of the component. So this will be what? This is the mass of the liquid phase multiplied by the specific volume of the liquid phase, and this is mass of the vapor phase multiplied by the specific volume of the vapor phase. So if we,
Isn't it the other way around?
sorry,
Isn't mass equal to volume times specific volume?
no, see, what is the unit of specific volume? Volume, specific volume is what?
Okay, it is
It is meter cube
per kg.
per kg. So when we multiply it with mass, we will get a meter cube quantity, which is the volume.
Okay.
Essentially, the specific volume is the volume per unit mass. So when we multiply it with the mass, we get the volume. Is it clear?
Yes, sir. Thank you.
Okay. So if we see this, it will be what? I am just cross multiplying this. So if we put in these values, we will find that it comes out a fraction equals to 1 by 80.11. Now, but this is not the dryness fraction essentially. So this is what the dryness fraction is, mass of the vapor by total mass of the mixture. So for that, we can do this. There is something called dividendo, right? I mean, where we can add the this upper portion to the lower portion in both the sides, and the ratio remains equal. So this is like plus this, if we add it, then here also if we add it, then the ratio will remain same. Okay, so that is 1 from the top, 1 from the top, it is added and the divisor, and here mg is added to the divisor, so the ratio will essentially remain correct, same. So this mg by ml plus mg, this becomes equal to the quality of the mixture. So therefore the quality of the mixture here, that is mg by total mass, this is equal to this 81.11, which comes out equal to 0.0123. Okay, so is it clear till now? This simplification, is it clear?
Yes, sir.
Okay, okay. So next what we'll do, we will calculate the specific volume at this stage. No, sorry. Yes, so we have already determined what is the uh, dryness fraction or the quality of the mixture in the stage 1. So let me put it 1 here, and from now here we will determine what is the stage 1 specific volume, total specific volume. So it with these values, actually 0.0010436. So this value comes out equal to 0.02159 meter cube per kg. So since again, like the previous problem, since the container here it is closed and rigid, container is closed and rigid, so therefore the specific volume, this V by M ratio, that is the specific volume, is equal to constant. Therefore this V2 is equal to V1. So now what is the second stage? The second stage is when the pressure of the mixture has reached 2 megapascal. So corresponding to 2 megapascal, again these are the values of the liquid specific volume and the vapor specific volume. So if we write it here, we are assuming that x2 is the quality of the mixture in the stage 2. These are in the stage 2, which are this pf2 and pg2. I'm not writing this down again. So this will be equal to this. So by simplification, directly we can find that the value of the quality here becomes 2074. So here the quality is 0.0123 and the quality here is 0.2074. So can you say which stage has more vapor? Anybody? Please unmute and say, what do you think? Which stage will have higher vapor content?
State 1.
State 1. Why?
Sorry, state 2.
Yeah. Again, why? State 2.
Because it has a greater dryness fraction.
Okay. Yeah. So since the dryness fraction, this value, this is essentially what? This is essentially the mass of the, this is essentially the mass of the gas by total mass. So the mass of the vapor will be, since the fraction is higher, so the mass of the vapor will be higher in the stage 2. So since x2 greater than x1, so final stage has higher vapor mass mass of vapor than initial stage. So are all these clear to all of you?
Yes, sir.
Okay. So these are, so with this, the questions for the session 1 has come to an end. If any of you has any doubt in any of these questions, you can ask, or you can also ask me in the discussion forum, but better that you can ask me here, so it is easier for me to discuss here. So I am open to questions now if anybody has any question.
Sir,
Yes.
can you share these PPTs?
Yes, actually, I will share these PPTs to the NPTEL team. I am
Okay, okay,
unsure that if this will be shared with you people, but I hope that this will be shared.
okay, okay. Thank you, sir.
Yeah, so it is actually up to them. We don't have any direct contact with you people.
Okay, okay, sir.
Okay. So, any question?
Uh, Sir, today you have explained the problems very simply and very conceptually.
Okay.
Thank you very much, sir. याने.
Okay, thank you. And I hope that you all will be attending the sessions on a regular basis.
Definitely, sir. याने.
Okay. Okay, so if there are no questions, then uh, should I stop the session?
Okay, sir. Thank you. Thank you very much,
Okay.
sir.
Okay. Okay. See you all next Friday from 6 to 7. Okay.
Okay.
Thank you. You may leave.
Thank you, sir.
Yeah, yeah. Thank you for attending.